Hi, it's Mr. Adams from High School. This is a video on sublevel notation, or simply electron configurations of the current model of the atom. We've seen that the current model contains principal energy levels, right? And within these principal energy levels are contained other energy levels called sublevels. The sublevels contain orbitals. Now, orbitals are simply regions where we're most likely to find electrons, and in the orbitals contain actual electrons. So there are different parts to it. Now, orbitals have these different shapes that go with them. This will be a particular s orbital. P orbitals look like this, and d orbitals look like this, and f will be more complex. Okay, so that's, and all these guys are located within the atom in a cloud of negative charge. Okay, now we can use the periodic table to help us with orbitals and to help us with the electrons. So once we know the numbers that go with orbitals and electrons and the sublevels, okay, we can then start writing the electron configurations. Well, the first thing is you need your periodic table, and you need to find the first two columns right here, okay? That will be called the S block, okay, for the S sublevel. All right. Now we notice there's two vertical columns right here, right? Now the vertical columns tell us the maximum number of electrons a sublevel can hold. So the S sublevel holds a max of 2 electrons. All right. And moving on, over this side to the right in yellow over here, this will be our P block, right, for the P sublevel. Now, if you count the verticals carefully, right, you will see that the P sublevel holds a max of 6 electrons. All right, so we have S and P done. Now we'll move to the middle right here in green. This will be the D block for the D sublevel. If you count the verticals, you would see that there's 10 verticals. All right, so that will be, okay, 10 electrons for the D sublevel. And likewise for the F block or the F sublevel, there would be 14 electrons maximum that can be held in that sublevel. All right, so we move on. If we now divide, right, okay, the max number of electrons by 2, that would give us the number of orbitals. So 2 divided by 2 would give us 1. 6 divided by 2 would give us 3. 10 divided by 2 would give us 5. And 14 divided by 2 would give us 7. So we have 1, 3, 5, 7. Now what is that telling us? That's simply telling us that the S sublevel always has 1 orbital, which holds 2 electrons. The P sublevel always has 3 orbitals. That will give me 6 electrons max, and so on. Okay, so remember, each orbital can hold a maximum of 2 electrons. So that's why we have that nice relationship between these numbers. Okay, so we can start now to write electron configurations. Now we can use a filling chart like this, okay, to help us write electron configurations. Now as we move on, we actually can look at the periodic table itself and write configurations without using a chart like this. But for now, we can use this chart right here. Now it simply goes from 1 to 7, 2 to 7, 3 to 7, 4 to 7, S, P, D's, and F's. Okay, so you can simply memorize that if you have to use it later on. Now, for something like hydrogen, right, you start at the very lowest energy level possible. That's the 1s, and you write 1s down. Okay, the 1 represents the energy level, principal energy level 1. The S represents a sublevel. Okay, and since we only have 1 electron in hydrogen, you put a little 1 as an exponent right there, and you're done. 1s1, you're done. Now, moving on to lithium, right, which has 3 electrons, you would follow the chart again. You would fill from the lowest again. You say 1s2 this time, because remember, moving back right here, S's, right, can hold a max of 2 electrons. Okay, so we say 1s2, that's filled. We move to the next energy level. That's lowest, that's 2s. We put 2s down. Now simply, lithium has 3 electrons. We used 2 of them right here. Okay, so what we're going to do, we'll put that 1 electron in the 2s. All right, so we have 1s2, 2s1 for lithium. Aluminum, okay, same principle. We just follow the lines. Okay, so it'll be 1s2, right? Okay, that's 1s2. This will be 2s2. Okay, remember, s is a filled with 2s, so we're going to move on. Now we come to the 2p, right? So we have to be a little careful. You write 2p down, right? But we know from experience that p's can hold a max of how many electrons? A max of 6 electrons, right? So we have to be careful. We write 6 in there. I'll keep counting the electrons. So we have 2 plus 2 plus 6. That's 10, all right? So we move on to the 3s. So that's going to give us 3s2. Okay, so that's 12 electrons accounted for, all right? Then we move over here to the 3p, all right? So it's going to be 3p1. So aluminum is 1s2, 2s2, 2p6, 3s2, 3p1. All right, we move on. Now calcium, right, has, if I'm not mistaken, 20 electrons. So it'll be 1s2, 2s2, 2p6, right? So 1s2, 2s2, 2p6, 3s2, all right? Now we move to the 3p's now. The 3p6. So we have 2 plus 2 is 4, 10, 12, and 6 is 18. Now we go to over here to s's again. So we go to 4s2, and you're done. Okay, that's 20 electrons right there. 2 plus 2, 4, plus 6 is 10, and the rest gives you 20. All right. Now one more thing before we finish. We notice, right, that 4s comes before 3d. Now the reason for that is something called orbital overlap, which is caused by repulsion. Okay, the more and more electrons we have, okay, of the same charge, same negative charge, repulsion occurs, and actually the 4s electrons get pushed in front of the 3ds. Okay, but the chart takes care of that for you, so you don't have to worry about memorizing it. Okay, as always, folks, hard work plus sacrifice equals success. Principal energy levels contain sublevels. Sublevels contain orbitals. Orbitals contain electrons. You can use your periodic table to determine the max number of electrons and the number of orbitals. Okay, and you don't violate the building code. Okay, you make sure your S's always have 2 max, your P's have 6 max, and so on, and you're good to go. Take care.